Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Welcome to the course of Theory of Automata CS311. It's lecture number 19, and today we will discuss about context-free grammars. Today's agenda is we will learn about context-free grammars, and after that we will see what are context-free languages and what are the role of context-free languages and context-free grammars, and how context-free languages are differs from context-free grammars. So what is a context-free grammars or CFGs? CFG stands for context-free grammar. It is an abbreviation, and it is a formal grammar which is used to generate all possible patterns of strings in a given formal language. So first of all, we should know that it is a formal grammar. Context-free grammar is not an ordinary is not different from an ordinary grammar, but it is a formal grammar, and which is used to generate all possible patterns of strings in a given formal language. The purpose of context-free grammar is to generate all possible patterns of strings, and you know what we mean by a pattern of a string. You have already studied in your previous lectures. We have generated different patterns of strings by using different regular expressions. So the purpose of context-free grammar is to generate all possible patterns of strings in a given formal language. And what is the use of context-free grammars? Context-free grammars, because we are studying context-free grammars in automata theory, and automata theory has a very big role in compiler construction and design. So the context-free grammars are used in compilers, and in particular for parsing, because parsing is the key step in compiler design and construction. So it takes a string-based program and figuring out what it means. So there are two things. First is called the syntax of a program, and the other is called the semantics of the program. So the second part, which is called semantics, is closely related to the context-free grammars, in which the parser, which is a component of a compiler, takes a string-based program and then it figure out what it means. So it deals with the semantics. So let me write this part of the program, which is using CFGs, is related to the semantics of the program. Okay, this is called semantics. When we talk about the meaning of the program, so it comes under the semantics portion, semantics phase. Okay, so in context-free grammars are used in compiler, and in which component of the compiler? The answer is the parser, or in parsing step, and it takes a string-based program. Because of what is our program? Our program, because when we write a code, when we write a single statement in a program, what does that statement means for a compiler? Basically, the one single line is a combination of different strings, because we terminate every line of code with a semicolon. This means that every line in the code is a string, and the purpose of the parser is to recognize that string and try to figure out its meaning. So that's why the context-free grammars are used in parsing step in compiler. Typically, CFGs or context-free grammars are used to define the high-level structure of a programming language, because if you know the high-level structure of a programming language in first phase, then it is very easy to dig in and try to understand the semantics of the program. So that's why CFGs are used to define the high-level structure of a programming language, and it does this with the help of the tree data structure. Figuring out how a particular string was derived tells us about its structure and meaning. So the first step, or the first task of the parser which takes context-free grammars or use context-free grammars. Uh, the first task is to figure out how a particular string was derived, and this tells us about its structure and meaning. So if one knows how a particular string was derived, then it is very easy to know about its structure and meaning. So if you know the derivation of a particular string, how it derives, how particular characters in the string derived, then you can know, you can judge or predict its structure and meaning. So context-free grammars are very useful in defining the structure. So in short, we can say that the purpose of context-free grammars is to define the structure of a program, is to define or to analyze or to understand the structure of a program, and it is a high-level structure. It is a high-level structure. With the help of context-free grammars, we can define the structure, or we define the structure of a program in a high level, in a high level hierarchy. In formal language theory, a context-free grammar is a formal grammar in which every production rule is of the form. So this is the rule which is called a production rule. Okay. Production rules means that it produces some strings. Why we call it a production rule? Because it means that with the help of this production rule, we can generate different strings. So in formal language theory, CFG or a context-free grammar is a formal grammar in which every production rule is of the form A is equal to alpha. Okay. This A implies that alpha. So remember this notion or notation for your own understanding, that formal languages or for context-free grammars in a formal is a formal grammar, and in which every production rule, this is called a production rule because with the help of this production rule we can generate different strings. We can generate so many strings, but there should be some rule, and that rule is called a production rule. Let's study about what these notations means, A and alpha, where A is a single non-terminal symbol, and alpha is a string of terminals and on non-terminals, and alpha can be empty. Okay, so remember that A is a non-terminal symbol. This means that all further strings are based on this symbol, and alpha, the string of terminals, means that we can replace alpha with different strings by using different rules, and it could be an empty string as well. So this is the short definition of this production rule, that A is a single non-terminal symbol and alpha is a string of terminals and or non-terminals, and it can be empty as well. So in short, we say this is a production rule. A formal grammar is considered context-free when its production rules can be applied regardless of the context of a non-terminal. So why we called a formal grammar a context-free grammar? Because its production rules can be applied. This is the main statement in which it says that when its production rules can be applied regardless of the context of the non-terminal. So if you write this as let's say A implies alpha, here A is a non-terminal. Okay, so it means that regardless of the context of a non-terminal, A is a non-terminal and alpha is a terminal or non-terminal, or it can be empty. This means that when we are generating strings, it does not mean that we are neglecting this part of the program, but we are using this somewhere else in the production of the strings. So that's why it is called the context free. No matter which symbol surrounded it, the single non-terminal on the left hand side can always be replaced by the right hand side. Okay, so that's why we call it a context free, because we can replace the substrings in this part further on with this part when we incorporate the same rule, like because we are replacing A with alpha. This means when we encounter an A in substrings, we can replace those strings substrings or sub characters with alpha. So that's why it is called a non-terminal. This is what we call what we distinguish it from a context sensitive grammars. So like context free grammars, there is another concept which is called context sensitive grammars, in which this rule is not applicable. So this is the main difference between a context sensitive grammar and context free grammar. Here you can see that the word sensitive means that there we need to follow some specific rules as it is, but in this concept which is called a context free, this means that we are not bounded to some specific rules. Although we are using some rules, but it does not mean that we cannot replace this non-terminal in substrings with some value like alpha as compared to context sensitive grammars. So uh, a formal grammar is essentially a set of production rules that describe all possible strings in a given formal language. So a formal grammar means that it is a set of production rules, and that those production rules describes all possible strings in a given formal language. What do we mean by a production rule? Production rules are simple replacements. Okay, like in previous we have seen this alpha is equal to a implies alpha. This means that this is a production rule, and production rules are simple replacements. Okay, we can replace a with this part alpha when we incorporate or see a in substrings. This means that we can replace a with alpha in substrings as well. So this is a production rule, and we generate different strings with the help of this production rule. And when we and what we mean by production rules are simple replacements. This means that we can replace substrings with the help of production rules. NP is the set of production rules or substitutions rules. We call this a production rules or substitution rules as well. And a production rule it has a particular form, and that particular form, first we write a non-terminal. Like in this case, we have seen that A is a non-terminal, and this symbol, this is called, implies that finite set of terminals and non-terminals. So this is the left hand side. We called it a left hand side, and this is the right hand side. Okay, this is the right hand side. So we on the right hand side we have different terminals and non-terminals, and on the left hand side we have only one particular concept, and that concept is called a non-terminal. So we replaced left hand side with right hand side when we found some non-terminals in our strings. Here you can see that there is also a non-terminal. Okay, so we can replace non-terminals with this part when we encounter non-terminal in the right hand side as well. So what is a terminal? These two concepts are very important in understanding this concept which is called context free grammars. First of all, we should know that there are some production rules in context free grammars with the help of which we can generate different strings, and after that there are two main components which is called non-terminal and a terminal. So what is a terminal? A terminal is a symbol which does not appear on the left hand side of any production. So you can see that the terminal will always appear on the right hand side, and grammar contains a set of terminal symbols. We call these terminal symbols the tokens, such as a plus sign or a minus sign or a asterisk or any other token defined by the lexical analyzer, such as identifiers. And what are these non-terminals? Non-terminals are the non-leaf nodes in a parse tree, because in short, the compiler is generating a parse tree when using context-free grammars. So that's why we called this is a non-terminal. Here is example. There are three tokens. This is a non-terminal symbol. Okay, and this is an ID is also a token, and expression is also a token, and this means that we can replace statement is equal to ID and expression when we encounter this in our further tokens. So this means that we can replace statement with ID and expression when we encounter statement in our substrings or strings. Okay, there can be multiple replacement rules for a given non-terminal symbol. As you know, what is a non-terminal and terminal, you have a clear distinction between a non-terminal and a terminal. So we can replace multiple. We can replace multiple times for a given non-terminal symbol. The language generated by a grammar is a set of all strings of terminal symbols. Terminal symbols always appear on the right hand side and non-terminal appears on the left hand side. So the language that is generated by using CFGs is the set of all strings of terminal symbols that can be derived by repeated rule applications for some particular non-terminal symbol. This is called a start symbol. Okay, because when we generate some strings, we always start with a start symbol with the help of which we can generate further strings. So the language that is generated by a grammar is a set of all strings of terminal symbols. So the strings, what are those strings? Those strings are the combination of terminal symbols, and those terminal symbols can be derived by repeated rule applications, because when we apply the rules repeatedly on on further substrings, then we can generate multiple strings at a time. Non-terminal symbols are used during the derivation process but may not appear in its final result string. So this is the main point in which we can see that the non-terminal symbols are used during the derivation process, because we are using non-terminal symbols in deriving more strings. But later on, when we are on the final result string, that non-terminal symbol will never appear. So languages generated by context-free grammars are known as context-free languages, and the context-free grammars arise in linguistics, where they are used to describe the structure of sentences and words in natural languages. So this is the main use of CFGs. They are used in linguistics and in computer science or information technology. They are heavily used in NLP. Okay, because that part which is called natural language processing, it has a great role in context-free grammars, because the task of the machine is to understand the human language. That's why we are using context-free grammars in this field as well. It's a very heavy use in natural language processing, which is a subfield of an AI. Okay, so why we are studying this concept? Because it has a very great role in linguistics and especially in natural language processing part of artificial intelligence, where they are used to describe the structure of sentences and words in the natural language. They were in fact invented by the linguistic Noam Chomsky for this purpose. Who is the inventor of this context-free grammar? The inventor name is Noam Chomsky. As I said before, it is a very heavy use in computer science as well. In an early application, grammars are used to describe the structure of programming languages, because how a computer understand a particular statement in a program. First, it takes to understand the structure, because when you understand the structure of a program, it's very easy to understand its semantics as well. So in a newer application, they are used in an essential part of the extensible markup language. Context-free grammars are heavily used or mostly used in XML, which stands for extensible markup language, and which is called the document type definition. Okay, so they have a very different role, vast variety of roles they are playing in computer science, information technology, natural language processing, and XML and document type definition. And these are used to describe context-free languages. Of context-free grammar is a set of recursive rules. This means that those rules are recursive in a sense that they are used repetitively and in generating more strings. That's why we call it the recursive rules. And as I said before, they are used to generate patterns of different strings. And a context-free grammar can describe all regular languages. This is a key point, that the CFGs can describe all regular languages, but they cannot describe all possible languages. They provide a precise mathematical definition that clearly rules out certain type of languages, because context-free grammars are used in regular languages, only in regular languages. That's why it needs or provides a precise mathematical definition. The formal definition means that context-free grammars are computationally traceable. It is possible to write a computer program which determines whether sentences are grammatically correct or not. Okay, so this is the key point, that the context-free grammars are computationally traceable. This means that we can determine, or we can predict that the sentences are grammatically correct or not in any programming language. So with the help of context-free grammars, we done this step. And it is studied in theoretical computer science, compiler design, and linguistics. CFGs are used to describe programming languages, because the first question that appears in student minds when studying a particular concept is that what is the role of this, or what is the application of this particular concept in computer science. So CFGs are used to describe programming languages and parser programs in compilers. And those programs can be generated automatically from the context-free grammars. On the left hand side, you can see this is a parse tree, because parsing is a basic step in compiler design, and the purpose of parsing is to understand the semantics of a program. So that's why when the parser is doing its work, it uses a tree concept. Here on the left hand side, you can see the tree. Okay, the tree concept, it is called a parse tree. It is called a parse tree. Okay, so what are the applications of CFGs? Applications of CFGs in data processing, NLP, natural language processing, human activities recognition, and neural networks, software engineering, requirement documentation. So these are all the application areas of context-free grammars. Okay, so context-free grammars are very as a heavy big role in different fields of computer science. So let's talk about components of CFGs or context-free grammars. We have studied the main concept, the background of CFGs. Now let's move on and see what are the components of context-free grammars. So a grammar can be used to describe the possible hierarchical structure of a program, because if you know the grammar, you can describe the possible structure of a program. So the components of context-free grammars, as I said before, a set of tokens known as terminal symbols, and you know that terminal symbols always appear on the right hand side. Okay, terminal symbols always appears on the right hand side, and we call those terminals as tokens. A set of non-terminals, and as you know that non-terminals will always appear on the left hand side, and non-terminals are replaced when we are generating further strings. A set of production rules, this is the third step. A set of productions where each production consists of non-terminals called the left hand side of the production, and arrow, and a sequence of tokens and or non-terminals called the right hand side of the production. So this is the main part, because why this is the main part, because with the help of this part we generate different strings, and to generate those strings we are using some particular rules, and we call those rules the production rules. Like we in the previous slides we have seen this concept. Okay, arrow and then alpha. So here is a non-terminal, and alpha is a terminal or a non-terminal, and this is an arrow. So, and this whole is called a production rule. Our designation of one or more non-terminals as a start symbol. So we can say that is a start symbol as well. Is a start symbol as well. A non-terminal is a start symbol as well. And for four components. It has four components. The token strings that can be derived from the start symbol from the language defined by the grammar. So let's deep dicker and see what are those specific terms like terminal symbols, non-terminal symbols. A set of terminal symbols which are characters that appear in the language string generated by the grammar. So these are the characters that appear in the language or strings, and those strings are generated by the grammar. Terminal symbols will never appear on the left hand side of the production rule and are always on the right hand side. So this is the main idea or main concept, that the terminal symbols will always appear on the right hand side and not on the left hand side. And what are the non-terminals? A set of non-terminals, or we call it as a variable or variables, which are placeholders, which means that they can be replaced later on in substrings for patterns of terminal symbols that can be generated by the non-terminal symbols. Okay, so non-terminal symbols or variables, because a variable uh, is replaced by some value later on, so that's why we called it a placeholder as well. These are the placeholders of patterns of terminal symbols that can be generated by the non-terminal symbols. And I know that non-terminal symbol will appear on the left hand side and terminal symbol will appear on the right hand side. That's why we called it's a non-terminal symbol, because they can be replaced later on in the generation of different strings. These are the symbols that will always appear on the left hand side of the production rules, though they can be included on the right hand side later on. So there are we should say that the non-terminal symbols are somewhat flexible, because they can appear on the left hand side and appear on the right hand side with terminal symbols. The strings that a CFG produces will contain only symbols from the set of non-terminal symbols. So because non-terminal symbols are used in generating different strings, and that's why the CFG produces strings will always contain only a symbols from the set of non-terminal symbols. We always, when strings are generating, those strings contains the replacements of non-terminal symbols. Let's talk about what are the production rules. Production rules, a set of production rules which are the rules for replacing non-terminal symbols. It's a very simple definition, that a set of production rules which are the rules for replacing a non-terminal symbols. Production rules have the following form, as you can see that variable, right arrow, string of variables, and terminals. So we have seen this rule multiple times. A implies alpha. Okay, A implies alpha. So this is the production rule syntax. And what are the start symbols? We called a start symbol as a non-terminal. Non-terminals are called start symbols. A start symbol which is special non-terminal symbol. Remember this point, that the start symbol is always a special non-terminal symbol that appears in that initial string generated by the programmer, by the grammar. So let's talk about the formal definition of context-free grammars. It can be described by a four-element tuple, which is V, summation sign R and S, where V is a finite set of variables which are non-terminals, because we can call V as a finite set of variables, and those variables are non-terminals. And summation is a finite set of terminal symbols disjoint from V, and R is a set of production rules where each production rule maps a variable to a string. We will see this later on when performing some task in CFGs. And S, which is a start symbol. So it has a four tuple, four components: V non-terminal symbols, summation terminal symbols, R is production rule, and S is the start symbol. So try to remember this point, that V is a finite set of variables and they are non-terminals. Okay, and summation stands for terminal symbols, R is a production rule, and S is a start symbol. How we create a CFG? So this is the rule. Try to remember these rules so that you can apply in questions, in numerical questions, when we are using context-free grammars in generating different strings. First of all, the first step is to start with a start symbol. Start with a start symbol and apply one production rule to the start symbol on the left hand side by replacing the start symbol with the right hand side of the production. This is the second concept. We start with the start symbol, and then slowly and gradually we are applying different production rules on the right hand side. Repeat the process of selecting non-terminal symbols in the string and replacing them with the right hand side of some corresponding production until all non-terminals have been replaced by terminal symbols. So this is the last step in which all non-terminals will be replaced by terminal symbols. It could be that not all production rules are used. So this is a special case. It is not necessary that we use all the production rules. Sometimes only one or two rules will be applied on all strings, and sometimes we use all production rules. So this is not a rigid condition in which we see that we apply all production rules. So let's see some examples of CFGs. Examples. So this is example number one. Construct a context-free grammar for the language having any number of A's over the set this alpha. Okay. So first of all, we should know the regular expression. A static is a regular expression, and this is also called a clean closure. So production rule for the regular expression is as follows. S is a non-terminal, and this is a terminal and a non-terminal, because you can see that as you can see that S because will always appear in this on the right hand side as well. So this means that we can replace S with AS later on when we are applying this rule. So this is a non S is a non-terminal, and this is a terminal. A is a terminal and S is a non-terminal. So this means that non-terminal will appear can appear on the right hand side as well, and S implies this epsilon or empty string as well. So these are the rules which we call the production rules for the regular expressions. Okay, this is a rule number one. So example number one, now we want to derive a string triple A. We can start with the start symbol S, and S implies that AS, and after that because here you can see that S is a non-terminal, we can replace S with AS. As you can see that we have replaced S with AS, then again S with AS, then again S with AS. Okay, so you can see that we are applying this production rule which is called a non-terminal multiple times on the right hand side. We can also replace S with epsilon as well, because in the previous slide you can see that S stands for A and S. Okay, and S is also epsilon as well. So you can see that we have replaced S multiple times on the right hand side, as AS, then AS, then AS, then AS, and then we replace S with epsilon because by using rule number 2, and at the end our strings ends over here. So this is how it works when using context-free grammars. So here regular expression is equal to epsilon, and it can generate a set of strings epsilon and so on. We can have null string because it's start symbol, and rule 2 is given that this. And let's move on another example which is construct a CFG for a language L, a raised to power n, b raised to power 2n, where n is greater than or equal to 1. So the strings can be generated for a given language in this fashion, and the grammar could be these are the production rules. S is a non-terminal, and at the same time it is a start symbol. ASBB or ABB. Okay, this means that we can replace S with this part or this part. This is a non-terminal, S is a non-terminal, and these are the terminal or non, because we can see that S appears again over here, so that's why we call it a non-terminal. So the right hand side is a combination of terminals and non-terminals, and this is called a production rule. Now we want to derive a string a b b 4 times b. We can start with the start symbol S, and we can replace S with a as bb, because the purpose is to generate this part a and 4 times b. So as you can see that we have replaced S with ABB. Okay, with ABB we have replaced S with ABB. This is, you can see that A, this is the first character, and then these two characters BB appears over here. Okay, and what is this part ABB? Because you can see that we have replaced S with ABB over here. So this is how we use CFGs and derive different strings. Example number 3, the grammar is as AB and PS with productions. We can replace S with A as A, with S B as B, and S with epsilon is a context free. A typical derivation in this grammar is this one. Okay, so this is a production rule. Try to understand this example by yourself. And this is an example number 4. This is the general information over here for arithmetic expressions, and start symbol is expression, and the terminal symbols are this, and the production rule, these are the production rules. Okay, these are the production rules. So with the help of production rules we can generate different strings. So try to study these concepts by yourself. You have now a basic idea of CFGs and what is called a derivation. Derivation is a sequence of production rules, and it is used to get the input string through these production rules, and during parsing we have to take two decisions. These are as follows. What are those two decisions? We have to decide the non-terminal which is to be replaced, and we have to decide the production rule by which the non-terminal will be replaced. So when we are deriving strings, we are using different decisions. And what are those decisions? Non-terminal which is to be replaced, and production rule by which the non-terminal will be replaced. Two options to decide which non-terminal to be replaced with production rule, which is called leftmost derivation, and is called a rightmost derivation. So let's study about the leftmost derivation first. As you can see that these are the production rules. E is equal to E plus E, and E is equal to E plus E minus E, and then E is equal to A or B. So here the input is A minus B plus A. So this is the input, and let's see how we can generate different strings with the help of this rule, which is called leftmost derivation. So here you can see that we are using, this is the right part and this is the left part. Here we replaced E with E minus E. Okay, and this part over here we use this rule, second rule over here. After that we have replaced E with A, this part. This is called leftmost derivation. And then we have used we have replaced E with B, this part again. And then we replaced E. We have used this rule, last rule, multiple times. So in this fashion we come to the end. Now let's talk about the rightmost derivation. We started from the right and replaced E with E plus E. We have used the first rule over here, and then similar fashion we have replaced E with A, E with B, and then E with A, and so on. So this is all about context-free grammar or CFGs. I hope you have understood the basic concepts of context-free grammars. Try to apply those concepts by using different numericals, which I will have a plan to give you as an exercise later on. So if you have any questions regarding today's lecture, you can email me on my email, and I will answer accordingly. Till your next lecture, Allah Hafiz, and see you soon, inshallah.